Let's talk some more about finding horizontal and oblique asymptotes. So first of all, a rational function may have a horizontal asymptote or an oblique asymptote, but not both. So always remember that. So we examine the degrees of the numerator and of the denominator of a rational function to determine its horizontal or oblique asymptotes. Okay, so we look at both the degree of the numerator and the degree of the denominator. So we're going to do some comparisons here. When the degree of the denominator is greater than the degree of the numerator, we will have a horizontal asymptote. So we don't really have to do anything. That horizontal asymptote is y equals 0. There is no work to do. So let's look at this example. When we see this, f of x equals x plus 2 divided by x minus 3 squared, the degree of the numerator is 1. The degree of the denominator is 2. If we multiply that out, we get x squared minus 6x plus 9. So the degree is 2. So we know we have a horizontal asymptote, which is the x-axis, whose equation is y equals 0. When we have equal degrees in the numerator and denominator, we also have a horizontal asymptote, but we do have some work to do. We're going to take the ratio of the leading coefficients. So we use the ratio of leading coefficients. So remember what a leading coefficient is. It is the number that's in front of the highest degree. So g of x has degree 2 in the numerator, degree 2 in the denominator, so those degrees are equal. And the leading coefficient of x squared, remember, is a 1. And the leading coefficient of the denominator's x squared term is 3. So the horizontal asymptote is y equals 1/3. Now finally, when the denominator is less than the numerator, we have two cases. So when it's exactly 1 degree less, we have an oblique asymptote. So we have to do polynomial long division, and we don't have to worry about the remainder, so we're always going to ignore the remainder. We just want to see what is the linear function, that is the oblique asymptote. So let's look at this example. H of x is given here, so we need to do long division. So we're going to put x squared minus x plus 1 outside of the division symbol, and we're going to put the numerator. If there were any missing terms, I'm going to put 0 placeholders, and the numerator does have a missing term of x squared. So I demonstrate that missing term was 0x squared. And then let's see, I'm going to have 3 terms outside of the division symbol, and I will go over 3 terms, and I'll be like, hey, here's an x right here, and I have an x squared here. So how do I get x times what to get x squared? Well, I need another x. So then I'm going to distribute x times x squared is x cubed, minus x times x is minus x squared, plus 1 times x is plus 1. But remember, in long division, we have to subtract all of those terms. So by design, this cancels, and 0 minus a negative x squared is positive x squared, and x minus an x is plus 0. I'd bring down the plus 1 because I have 3 terms on the outside of the division symbol. So now I need to eliminate x squared, and I have a 1 here. So I just need to say plus 1, because by design, long division, 1 times x squared. I want to eliminate the highest degree term in the process. And then 1 times negative x is minus x, and then 1 times 1 is plus x. Now I don't even really have to complete this last step. I could if I wanted to, but again, I can ignore the remainder, but by design that eliminates, because I'm subtracting that whole trinomial from the one above it, and 0 minus negative x is positive x, and 1 minus 1 is 1. So this is the remainder, but I don't even care about it because I have my oblique asymptote in the quotient there. So y equals x plus 1 is the oblique asymptote. So exactly 1 degree less in the denominator from the numerator, or you could think of the numerator as 1 degree more. Now the other case, when the denominator is less than the numerator and there's more than 1 degree less, then we have no asymptote. We don't have anything to do here, and here's an example of one. We have x to the 5th degree, so degree is 5, and we have x to the 3rd degree, so degree is 3, so we have no horizontal or oblique asymptote.